Hi guys, in today's class I'll be talking about calculus in an explicit form. So calculus is basically everything about differentiation and integration, right? So by differentiation, let's say y is a function of x, and if I try to find the rate of change of y with respect to x, that's differentiation. While integration, let's say now I try to find the area or volume of a particular shape or volume of a space, that's integration. Now I'll try to cover differentiation in this section of the video. So what are we expected to know? We are expected to know limit of a function, differentiation of explicit function, algebraic, simple and trigonometrical functions, sine, cosine. Candidates should be able to find the limit of a function, differentiate explicit, algebraic and simple trigonometrical functions. So now, what is our explicit function? First of all, we have to understand the various types of function we have. We have explicit function, we have implicit functions, right? Now, if you have a function y is a function of x, this f means function. So if I say y is a function of x, this y is my dependent variable. We call this your dependent variable. Why this x, function of x due? This is your function of x due. Independent variable. Right? By dependent, what do I mean? Dependent means it needs the other help of the. Okay, if I say I'm dependent on you, that means I need your help. If I say I'm dependent on you for this my channel to get more views, that means I need your help for my channel to get more views. But if I now say independent, what do I mean? That means I don't require anybody. I can stand on my own independent. That's not independent. So y is a function of x. Y is the dependent variable. Why the function of x is your independent variable. That means my y depends on x. Now this type of function is known as my explicit function. Why do I call it explicit function? Explicit function in the sense that it always depends on a single variable, not various variables, right? If I now have something like this, so this is regarded as my explicit function. Right? Explicit function in the sense that it depends on only one variable, only a single variable. But if I now say implicit function, if I have something like this, y is a function of x and y. That means my y depends on x and y. If you have a function in terms of x and y, this is your implicit function. So implicit function in the sense that it depends on more than one variables, right? So now if I'm trying to find the rate of change of y with respect to x, that's called differentiation. If I try to find the rate of change of y with respect to x, or if I find the gradient function of y with respect to x, or if I'm finding the derivative coefficient of y with respect to x, that's what differentiation. So do you understand? So that's the idea of differentiation comes to play. If you have a question, they say, differentiate this, that's differentiation. Find the rate of change of y with respect to x, that's differentiation. What is the differential coefficient of this? That's what differentiation. Or they say, what is the gradient function of y? That's what differentiation. Now, for my explicit function, remember, it depends on only one variable. That's my total differentiation. That means I'm finding the total differentiation of that particular function. But if I'm now having implicit functions, whereby my y depends on several variables, x, y, and z, that's partial differentiation. That's partial derivatives. So for this your level, I'll just be explaining basically explicit function. So now if I have y to be a function of x, and I'm asked to get the y of the x, that's y to be a function of x. The y means I'm finding I'm differentiating my y with respect to x. So this dy dx can be called the rate of change of y with respect to x. One, either you see this or you see this, the gradient function of y, or you see this, the differential coefficient. The differential coefficient of y. Right? So these are the three names. Either you say differentiate or find the rate of change of y with respect to it, or the graded function of y, or the differential coefficient of y. Now you must understand the term differentiate with respect to. Now what do they mean? That means they want us to differentiate our y with respect to x. That means our y we are differentiating it with respect to, that means I'm giving regards to my x, right? Now, if you have a function, if you have a function y to be equal to ax raised to power n, right? If you have a function y equals to ax raised to power n, and I'm asked to differentiate this dy dx, that means I'm differentiating this with respect to x, right? I'm differentiating my y with respect to x. What will I do? It means I'm doing 9 times a x raised to power n minus 1. I'll use this my power of x to multiply the coefficient of x. That's n times a x raised to power n minus 1. So this is general form of differentiation. Recall, our differentiation can be rate of change of y with respect to x, the gradient function of y, the differential coefficient of y, and calculus is not only differentiation, calculus is differentiation and integration, right? So now, let's go to differentiation of monomial terms. Differentiation of monomial terms. Differentiation of monomial terms. So I'm moving to differentiation of monomial terms. Differentiation of monomial terms, right? So now, if I have this, if I have y equals to 5x raised to power 4, this is a monomial term. So, and I'm asked to differentiate this, right? Recall, if you have y equals to ax raised to power n, and I'm differentiating with dy dx, recall what I said, is n times a x raised to power n minus 1, right? So, we'll be following this rule. We'll be following this rule to solve all our differentiation questions. N times a x raised to power n minus 1. Now to differentiate this, they say differentiate this, or they can say find dy dx. Find dy dx. This is pronounced dy dx. Dy dx. So I'm differentiating y with respect to x, right? Following my rule, it's what? 4 times 5. 4 times 5. X raised to power 4 minus 1, right? The power of the variable I'm differentiating times the coefficient of the variable, then I subtract 1 from that same power of my variable. The power of the variable is 4 times the coefficient, that's 4 times 5. X raised to my big variable. I'll subtract 1 from the power of that my variable, that's 4 minus 1. So imagine 4 times 5 was 20. X raised to power, what's 4 minus 1? 3. Right? So my dy dx is what? My dy dx is what? 20x cubed. Right? Let's take another example. If you have y to be equals to 6s cubed, and you ask me find the gradient function of y, find the gradient function of y, that means differentiate y with respect to x. That's dy dx. Right? The power of my variable, we call the power of my variable, multiply the coefficient of my variable, that's 3 times 6, right? X raised to power. I'll subtract 1 from the power of my variable, that's 3 minus 1, right? 3 times 6 is what? 18. X raised to power. 3 minus 1 is what? 2. As you can see, 18x squared. 18x squared. Right? The power is what? 3. I'll use the power to multiply the coefficient of the variable, that's 3 times 6. Then I subtract 1 from the power, 3 minus 1. So 3 minus 1 is what? 2. X raised to power 2. 3 times 6 is what? 18. 18x squared. Let's solve another question. if you have y is equals to 8x raised to the power of 5, then you have to differentiate this. Or they say find the rate of change of y with respect to x. So that means differentiate y with respect to x. Right? I'll use this power of x, that's 5. So multiply the coefficient of the variable of x. And what's my coefficient? 8. Right? Then x, I'll subtract 1 from the power, that's 5 minus 1. 5 times 8 is 40. X raised to the power. 5 minus 1 is 4. So that's 40x raised to the power 4. Right? Now, let's take it to a complex level now. If you have something like this. So this is my answer. If you have something like this now, y equals to 2x raised to the power minus 2. So don't be scared if you see a negative power. It's still the same rule. Find the gradient function of y. That's dy dx. Dy dx. Right? So I'm having the power multiplied by the coefficient. Minus 3 times 2, right? X raised to the power, I'll subtract 1 from this power. Minus 3 minus 1. So I'm having minus 3 times 2, that's what? Minus 6. X raised to the power what? Minus 3 minus 1 is what? Minus 4. Right? Now, if you are leaving your answer, you don't make your variable to be in negative form. You further simplify. Your variable should not be in negative form. You further simplify. This minus 6x raised to the power minus 4 now. This minus 6x, this minus 6x raised to the power minus 4 can be written as minus 6 times 1 over x raised to the power 4. Using our indices, if you have a raised to the power minus b, it is the same thing as saying 1 over a raised to the power b. Right? So that means we have 2 raised to the power minus 3. The same thing as saying 1 over 2 raised to the power 3. Because I want to remove this negative sign. If I have x raised to the power minus 2, it's same as saying 1 over x raised to the power 2. If I have x raised to the power minus 3, it's same as saying 1 over x raised to the power 3. If you have q raised to the power minus 5, it's same as saying 1 over q raised to the power 5. So that's what I did here. X raised to the power minus 4 is same as saying 1 over x raised to the power 4. And I know that minus 6 times 1 is what? Minus 6 over what? X raised to the power 4. So my dy dx is what? Minus 6 over x raised to the power 4. Can you see? Very easy. I'll just use my power to multiply my coefficient, then I subtract 1 from that same power. So minus 3 times 2 minus 6. Minus 3 minus 1 minus 2. So I'm having minus 6 x raised to the power minus 4. Then using my indices, I know that x raised to the power minus 4 is same as 1 over x raised to the power 4. So I'm having minus 6 times 1 minus 7 over x raised to the power 4. Now let's move to some key things. So I'll be releasing keys in this question. Keys that will help us further when we are going to advanced calculus. So there are some key things, keys knowledge you must know. There are some key knowledge you must know, some key things you must know. Right? So now the first key is key 1. Key 1. First key now. If you are differentiating a constant, the result is always 0. That is the differential coefficient of a constant is what? 0. If you differentiate a constant, it's always what? 0. Now what do I mean by this? I'll show you. Anytime you are differentiating a constant, your result is always 0. What do I mean by this? If you have y equals to 2, right? You are asked to differentiate this with respect to x. You are asked to differentiate with respect to x. This is a constant. Constant means does not have any variable, right? It's a constant and that means does not have any variable. Constant term means values that don't have any variable. What are variables? Variables are letters. Letters A, B, C to Z. Those are variables. Y constant term means it doesn't have any variable. So I'm having y equals to 2. I'm asked to differentiate this with respect to x. I'm differentiating this with respect to x now. So I can have y equals to 2x raised to the power 0. Why did I include this x raised to the power 0? Because I'm asked that I should differentiate my y with respect to what? X. That means I must include what? X in my function. Do you understand? As soon as I'm being asked to differentiate y with respect to t, I must include t in my function. As soon as I'm asked to differentiate y with respect to z, I must include z in my function. As soon as I'm asked to differentiate y with respect to q, I must include q in my function. Do you understand? But in this question, I'm asked to differentiate y with respect to x. That means I will include x in my function. Now, what is the meaning? If I'm including my x now, it's what? X raised to power 0. Why? X raised to power 0 is what? 1. Remember our indices. X raised to power 0 is what? 1. 1 raised to power 0 is what? 1. 2 raised to power 0 is what? 1. Aside from 0 raised to power 0, which is what? Indeterminate. Indeterminate. So, x raised to power 0 is what? 1. Anything raised to power 0 is 1. Aside from 0 raised to power 0, which is indeterminate. So, we understand that. So, this is the same thing as what? This. Do you understand? This x raised to power 2 x raised to power 0 is the same thing as this 2. Look at what I'm saying. If you have 2 and I have 2 x raised to power 0, it's the same thing I'm saying. Look at 2. What's x raised to power 0? X raised to power 0 is what? 1. What's 2 times 1? It's not 2. This is the same thing. I just included the x raised to power 0 because I'm asked to differentiate with respect to x. So now I'm differentiating this, the y, the x, right? Recall the same way. This is my power, I will multiply my coefficient. So I'm having 0 times 2, right? X raised to power 0 minus 1, right? My power will multiply my coefficient, 0 times 2, x power 0 minus 1. Now, if you have 0 times 2, you have 0. X raised to power 0 minus 1 dot minus 1. Remember, 0 times the whole of this will give me what? 0. So you can see the differential coefficient. If you are differentiating a constant, the result is always 0. That means the derivative coefficient of a constant is always 0, as you can see. So that means my y dx is 0. Let's try it for another thing. If you have y equals to 5, and you have to differentiate this with respect to t, with respect to t now, not x, you have to differentiate it with respect to t now. So I'm having y equals to 5t raised to power 0. Remember, 5t raised to power 0 is the same as saying 5. That is, we have 5t raised to power 0. That's 5 times. What's t raised to power 0? T raised to power 0 is 1. What's 5 times 1? 5. This is still the same thing. I just have to include the t because they asked me that I should differentiate with respect to t. As long as I'm asked to differentiate with respect to w, I'll put w raised to power 0. If I'm asked to differentiate with respect to z, I'll put z raised to power 0. So because I'm asked to differentiate with respect to t, I put t raised to power 0. So I'm having y equals to 5t raised to power 0. That means I'm having dy what? Divide what? dt. Dy dt. No longer dy dx. It was dy dx because my y was dependent on what? X. But now my y is dependent on what? T. So that's what? Dy dt. The same thing applies. So I'm having 0 times 5, right? T raised to power 0 minus 1. I know that 0 times 5 is what? 0. T raised to power 0 minus 1 is 1. Remember, this dot means times. 0 minus 1 is 1 minus 1. So I'm having 0 times 0 of this is 0. So you can confirm that if you are differentiating a constant, the result is always 0. So let's keep this in mind. So this is our bullet point 2. The derivative coefficient. The derivative coefficient of a constant is what? 0. Right? Key 2. This is important as we are going to be differentiating many more things. So we have to have this basic foundation. Key 2 now. Key 2. Our second key. Key 2. If you are differentiating a variable, with power of 1, the derivative coefficient is always the coefficient of the variable. Right? So if you are differentiating a variable with power of 1, the derivative coefficient is always the coefficient of that variable. What do I mean by this statement? Now, anytime I'm differentiating a variable that has the power of 1, that's any variable with power of 1, the derivative of that variable, that's when I differentiate that variable, at my result will be what? The coefficient of that variable. Now I'll explain this on the board. Now, what do I mean by power? Power is same thing as index. It's always at the top right corner of your variable. Because variable is what? Your letter. Power or index is or your exponent is always at the top right corner of your variable. So if you have y equals to x, right? Now, this my variable. Remember, variable is your letter. It has a power of what? 1. Top right corner. Remember, x raised power 1 is what? X. Remember our indices. If you have 2 raised power 1, that's what? 2. 3 raised power 1, that's what? 3. That's why you are not seeing the 1 here. It's invisible. So that's why you are not seeing it. So this x is same as what? X raised power 1. So now if I'm differentiating this now with respect to x, so I'm having the y, the x, right? There's a coefficient. So what's the coefficient of this x? 1. This 1 is still the same thing as x. Look at what I'm saying. If you have x, it's the same as saying 1 times x raised power 1. Abi? X raised power 1 is what? X times 1 is what? X. Can you see? So there's a 1 here. So this one will multiply this coefficient. So I'm having 1 times 1, right? X raised power 1 minus 1. I'm subtracting 1 from the power. So the power will multiply the coefficient. That's 1 times 1. X raised power 1 minus 1. So I'm having, what's 1 times 1? 1. X raised power. What's 1 minus 1? 0. Right? Dot. This dot means multiplication. So I'm having 1 times, what's x raised power 0? 1. What's 1 times 1? I see. When I differentiate this, it gave me the coefficient at the later 1. The coefficient always is 1. The coefficient is always behind it. It's that number that is multiplying the variable. Your coefficient is the number multiplying your variable. Note, your coefficient is that number multiplying your variable. So in this variable x, which has power of 1, my coefficient was 1. This is when I differentiate it at the later end, I later obtain the coefficient 1 back. Now let's do another one here. Let's have another question. If you have y equals to 3x, right? You notice that in this question, my power is what? 1. Right? If you don't see any number here, you assume it to be 1. It's invisible, it's 1. So now if I want to differentiate this now, at the later end I should get 3. Because 3 is the one multiplying x. Remember, coefficient is that value multiplying my variable. So I'm having here, let's differentiate now. I'm having dy dx, right? That will be 1 times 3, x raised power 1 minus 1, right? What's 1 times 3? 3. X raised power. What's 1 minus 1? 0, right? So I'm having 3. X raised power 0 is what? 1. 3 times 1 is what? 3. As you can see. Later giving it the coefficient of this variable. So the derivative coefficient of any variable with the power of 1 is always the coefficient of that variable. Let's take another one again. If you have y to be equals to 5 over 2x, if I differentiate this, it will give me 5 over 2. Let me show you. So we are having dy dx, right? So we have here to be 1. So I'm having 1 times 5 over 2, right? X is power 1 minus 1. Right? So what's 1 times 5 over 2? That's what? 5 over 2. X is power. What's 1 minus 1? 0. So I'm having 5 over 2. X is power 0 is what? 1. 5 over 2 times 1 is what? 5 over 2. Can you see? It gave me back this. So I'll add it to my bullet points. I'll add this to my bullet points. So now that we all know this, that means the differentiation, the derivative coefficient of any variable with the power of 1 is always the coefficient. It's always the coefficient of the variable. So now, these are the three things, these 3 points, these 3 key are going to guide us in differentiation. So it's important to understand it. I've explained it. So that means if you have y equals a raised power n, if you differentiate it using our, so the power will multiply the coefficient, that's n times a, then you are subtracting 1 from the power. The derivative coefficient of a constant term. Remember, a constant term is any term that which does not have any variable. And I explained what a variable is. Variable means letters. Anything that has letters is a variable. Letters A to Z. Those are variables. So constant term, any value which does not have variable, like your 1, 2, 3 to infinity, those are constant term. So what then I say what coefficient are? Coefficient is that number that is multiplying the variable. So let me explain this. If you have 2x now, this is my coefficient. Right? This is my what? Variable. And this number here is my power. If I have 2, these 2 here is regarded as my constant term. If I have 2, this is my constant term also. So now, when I say the derivative coefficient of a constant term, that means I have y to be a function of 2. If I'm differentiating this, the derivative coefficient of this is always what? 0. Now the second condition is the derivative coefficient of any variable with the power of 1. That means any variable x, a, b, q, in as much as it has what? A power of 1. 1, here is 1. The power here is 1. If no same power, just is 1. When I differentiate all this variable, when I differentiate all this, if I differentiate this and this with respect to the variable, it is always the coefficient. Now the coefficient of x is what? 1. That means if I differentiate this, it will give me 1. The coefficient of a is what? 2. That means if I differentiate this, it will give me 2. The coefficient of b is what? 5 over 2. That means if I differentiate this, is what? 5 over 2. The coefficient of q is what? 4. That means if I differentiate this, it will give me what? 4. So that's what this second bullet point is saying. The derivative coefficient of any variable with the power of 1 is always the coefficient of that variable. I hope that's clear. So now, I want to give some tricky questions to further clarify our understanding of differentiation with respect to any variable. So if I have y equals to 4a squared x, right? I'll use this to explain something. Now if I want to differentiate y, if I'm asked to differentiate y with respect to x, right? If I'm asked to find 1 dy dx, 2 dy dA, 3 dy dq. That means I am differentiating my y with respect to x. I'm also differentiating my y with respect to a. I'm also differentiating my y with respect to q. So I'll be solving this individually. So in this question, I'm asked to find, first question asks me to find the y dx, right? I know my function is what? Y equals to 4a squared x. Now if I'm differentiating my y with respect to x, recall it is the power of my x I will use to multiply this. So I'm having here to be 1, right? So I'm having 1 times the coefficient of x is what? 4a squared. Remember, coefficient is that one multiplying the variable. In this case, x is our variable. The rest of it will be taken as our coefficient. This is our variable because we are differentiating with respect to x. So this becomes our variable. While the rest, the remaining part becomes our coefficient. Coefficient is that part that multiplies the variable. So this 4a squared becomes our coefficient. So I'm having 1 times 4a squared, right? X raised to power what? 1 minus 1. Recall, n minus 1. That's what I have here. So I'm having 1 times 4a squared will give what? 4a squared. 2 times 1, 2, 3 times 1, 3. So 1 times 4a squared will give back that 4a squared. X raised to power what? What's 1 minus 1? 0. 4a squared. X raised to power 0 is what? 1. 4a squared times 1 is what? 4a squared. So this will give me my dy dx. Now look at this question. I am differentiating y with respect to x. Now, remember our third bullet point. Our third bullet point said that the derivative coefficient of any variable with the power of 1 is always the coefficient of the variable. Look at it. I'm differentiating this with respect to what? X. I'm differentiating y with respect to x. And my derivative, my variable is what? X. And what is the power of my variable? 1. So recall, I told you, anything aside from the variable, anything aside from this x is taken as my coefficient. So the derivative coefficient of any variable with the power of 1 is always what? The coefficient. That means if I differentiate y with respect to this x, it will give me what? 4a squared. Let me reiterate what I just finished saying. Now I'm differentiating y with respect to x, right? I know that the power of my x is what? 1. The power of x here is what? 1, right? Because I'm differentiating y with respect to x, and I know that my variable that I'm differentiating with has a power of 1. That means my differential coefficient will be what? The coefficient of the variable. This is the x, the variable I'm differentiating. The rest is what? My coefficient. So if I differentiate this, my answer will just be 4a squared, which is what I got here. Can you now see how this is being applied to the question? Why is it 4a squared? Because the variable has what? A power of 1. I hope that's clear. Because I'm differentiating x, and my x has a power of 1. So when I differentiate it, it will be what? The coefficient. Now let's do dy dA. Dy dA. Dy dA now. So I'm having y to be equals to 4a squared x. 4a squared x, right? And I'm asked to find dy dA. Now in this question, I'm asked to differentiate y with respect to what? Is it with respect to x? No, I'm not differentiating with respect to x now, but I'm differentiating with respect to what? A, because that's what is here. We are differentiating y with respect to a. So that means I'm finding the derivative coefficient of y with respect to what? A. With respect to means regarding a. I'm giving a respect. I'm regarding a. So I'm differentiating y with respect to a. That means everything I'm doing will just be concerned with what? A. This is what I'm saying. So now, if I'm differentiating this, the power, which is what? 2, we multiply everything. So I'm having 2 times. Remember, this 4a squared can be written as what? 4xa squared. Right? This 4a squared, x can be written as 4xa squared. It's still the same thing. I just rearrange it to make it more, to simplify it for you. This 4a squared, x can be written as 4xa squared. I rearrange it. So this is what? 2 times 4x, right? Then a raised to power 2 minus 1, right? 2. I just rearrange this to simplify it. So 2 times 4x, a raised to power 2 minus 1. Since I am differentiating with respect to a, the rest of them becomes my what? Coefficient of a, which is what? 4x. So I'm having 2 times 4x. Then I subtract 1 from that power of the variable I'm differentiating. That's what? 2 minus 1. What's 2 times 4x? 2 times 4x is what? 8x. A raised to power 2 minus 1. What's 2 minus 1? 1. So I'm having 8xa. So how can I leave it like this? 8ax. Now you notice that this did not give me back 4x, right? Because the power of my a is what? 2 and not 1. Assuming the power of my a is 1, if I differentiate this is what? 4x. You can try it. If you differentiate this with a having a power of 1, if I find the derivative coefficient of y, it's what? 4x. Let me recap. Now they ask me to find the y dA. That means I should differentiate y with respect to what? A. That's what I'm being asked to find. So now I'm having 4a squared x. I rearrange it to simplify it very well and make it my work clean and neat. So I'm having 4a squared, right? Dy dA now. I'll be differentiating anything I'm doing will be with respect to it. Anything I'm doing is just I'm giving regards to a. So I'm having a squared. I'll multiply everything by the power. That's what? 2 times 4xa, right? Then I subtract 1 from the power of a. That's 2 minus 1. From here. 2 times 4xa. Then I subtract 1. 2 minus 1. So I'm having 2 times 4 is what? 8. My x. Then a. 2 minus 1 is what? 1. This is what I did. 2 times 4, 8. Then my x, I brought it down. My a. 2 minus 1 is what? 1. So I'm having 8x. What's a raised to power 1? 8. So this is 8xa or 8ax. Now let's look at this third one. You're having y to be 4a squared x, right? And I've been asked to find the y dq. The y dq. Now look at this. This might be a little bit tricky now. You have to pay rapt attention. I'm about to find the y, the q. In this my function, do I have q here? No, I don't have q in this function. I'll have to include q in the function for me to differentiate y with respect to what? Q, right? So I'm having 4a squared x q raised power what? 0, right? 4a squared x q raised power what? 0. Remember, q raised power 0 is same as what? Q raised power 0 is what? 1. That's 4a squared x times 1, which is same as 4a squared x. I just include this q raised power 0 so that I can differentiate y with respect to q. Now I'm differentiating this. I'll be having 0 times the whole of this. So I'm having 0 times 4a squared x, right? Q raised power 0 minus 1. 0 times this will give me what? 0 times q raised power what? Minus 1. Remember, at the end of the day, 0 times this will give me what? 0. So my dy gets what? 0. Can you see what I'm saying? So I'm having y equals to 4a squared x q raised power 0. I'm differentiating this with respect to q. That was why I include q raised power 0. Recall, this is my original function. My original function was 4a squared x. But I'm asked to differentiate y with respect to q. So I will include q in my function. So if I'm including q in this function, I'm having 4a squared x q raised power 0. Right? Recall that 4a squared x q raised power 0 is what? 1. So this is it as saying 4a squared x. So I got back the same thing. This is still the same thing. It's still the same thing. This q raised power 0 is because I want to differentiate this y with respect to q. So I just include q raised power 0, and I know that q raised power 0 is what? 1, which I have here. So I'm having 4a squared x times 1, that's 4a squared x, which is the same thing here. Then I differentiated it with respect to q, that's 0 times 0 of this. At the end of the day, I'm obtaining 0. Now this brings us back to our bullet point 1, which says the derivative coefficient of a constant term is what? 0. Now, look at this. My function was originally 4a squared, right? This was my original function, right? But since they say that you find dy dq, I have to include q in my function, right? Because I'm differentiating y with respect to q. I'm not differentiating with respect to a, neither am I differentiating with respect to x. Rather, I'm differentiating with respect to q. That was why I included what? 4a squared x q raised power 0. Q raised power 0 is what? 1, recall. So I'm saying 4a squared x into 1. And this my 1 is a what? A constant term. And I told you that anytime you're finding, when you're differentiating a constant term, it's always what? 0. That was why we obtained 0 at the end of our differentiation. Because this our q is a constant term, it's not in the function. We gave it a power of 0. That means q raised power 0 is 1. That means we are saying we are differentiating a constant term indirectly. So we are differentiating 1. And when you differentiate 1, which is a constant term, is what? 0. So that's why you obtain 0 here. So next one, we'll be moving to differentiation of polynomial functions, polynomial terms. So we differentiating polynomial terms. So we differentiating polynomial terms. Now, we have y equals to 4x cubed plus 2x squared minus 6x plus 3. Okay, let's just use plus for instance. So I'm asked to find the y dx. Find the y dx. Find the y dx. I'm differentiating this with respect to what? X now. The y dx now. The y dx. If I want to differentiate 4x cubed, remember the power will multiply the coefficient. So I'm having 3 times 4, right? X raised power, I'll subtract 1 from here. 3 minus 1 plus the power will multiply the coefficient, that's what? 2 times 2, right? X raised power what? 2 minus 1. I subtracted 1 from the power. Plus, recall there's an invisible 1 here. If you don't see any power here, just put 1. So I'm having 1 times 6, right? X raised power what? 1 minus 1. Plus, recall our rule. if you differentiate a constant term, 3 is a what? Constant term, it does not have any variable. And anytime I differentiate a constant term, it's always what? 0. Automatically is what? 0. You see it? See the importance of the rule. If you differentiate a constant term is always what? 0. So I'm having 3 times 4 is what? 12. X 3 minus 1, 2. Plus 2 times 2 is what? 4. X 2 minus 1 is what? 1. Plus 1 times 6 is what? 6. X 1 minus 1 is what? 0. Plus 0, there's no need to write plus 0 now. There's no need. Plus 0, there's no need to write it. So I'm having 12x squared plus 4. X raised to the power 1 is what? X. Recall. 2 raised to the power 1 is what? 2. 3 raised to the power 1 is what? 3. 4 raised to the power 1 is what? 4. X raised to the power 1 is what? X. Q raised to the power 1 is what? Q. P raised to the power 1 is what? P. So x raised to the power 1 is what? X. Plus 6. X raised to the power 0 is what? 1. Right? 2 raised to the power 0 is 1. 3 raised to the power 0 is 1. 4 raised to the power 0 is 1. So I'm having 12x squared plus 4x plus 6. So my dy dx is 12x squared plus 4x plus 6. Can you see? Quite easily done. Very easy. Do you see it? Very easy. Differentiate with respect to x. Let's take another example. Let's take another example. If you have y to be 3x cubed, now be moving to complex of 3x cubed, okay, 3x raised to the power 4 plus 2x raised to the power 3 minus 5x squared minus